Can you guys think of any limitation of this data structure, the implementing of the stack this way?
A few moments later.
So the stack has a fixed size, right? So size, first limitation that it has, the fixed size limit. And the second limitation is that whatever the limitations of arrays are, since the underlying data structure is array only, so the same limitation applies on the stack also. So for example, if the memory is fragmented and I cannot use array in that case, so same way this stack which is using underlying implementation of an array can also not be used. So all the limitation that an array has, the stack also get all those limitations because its underlying data structure is array, right? So first of all, let's try to sort this problem out, fixed size limitation. How can we sort it out if we still have to continue using the array?
When
So
we are reaching near the capacity, then we can increase the capacity of the array.
yes, this makes sense. So what it means is that initially we designed one array. So we kept on pushing the elements. At that time is full is true. Now in this case, as soon as it happens, create a array, double its size. So normally we have an original array, and as soon as it is full, what I do, I create an array of the size twice of it, and I copy all this array, right? So we can do this change here. So if the array is full, instead of throwing this, what we do is that create a, and you make capacity twice, and copy elements from. Now, can you tell me if this happens, what will be the time complexity of this one, this whole process?
Order of n.
Order of
N.
right? Yes, it is obvious, right? So first of all, you have to define. So first of all, you need to have an extra space, and then one after the another, you have to iterate the previous array and put it into the new array. So this will take on your linear for loop. For loop will be needed, which is each and every element has to go 3 will go here, then 4 will come here, 5 will come here. It will take one loop, one for loop it will be needing. So that is why the time complexity of this operation will be. So now we have sorted out one challenge. Another challenge here is that the push and the pop, the contract of the stack is that the push and the pop should be constant. But at one moment of a time when the stack is going to overflow, at that time when it is trying to double its capacity, at that time the time complexity of the push operation doesn't remains constant. So this is one of the biggest limits. So it leads to the performance impact of the stack, right?
Vishnu, I have one question here.
Yeah, please.
We gave this example, right? That if there are fixed size limitation, then we can increase the size, and we have doubled it. But what if the stack is at a full condition and we just increment the size by 1?
So if you increment the size by 1, what will happen is that, see, what we are doing in this case, whenever we have to see the same array size cannot be incremented. This is one thing, right? So whenever you have to, increment the size of an array, always you'll have to, what you have to do, you have to create. So suppose initially my array was of size say 3. So I have element like 1, 5, and 7. Now I have to add 8 into this one. So you are saying that let's create, suppose 9. Let's create one more, another array of the size 5. So I have 7, 9, and then go and 8 into this. And again, if I have to add, let's create another one. And then say here 9. Now the problem with this approach is that, so every time when you create an array, it takes some time to initialize that array. So this is one thing. So every time if you say that, with every push, if I'm going to create an array, this will require the copying of all the data from this to this. from this to this, right? So every push operation will become order of the now n. So time complexity, which was initially order of 1, and because of this dynamic sizing intermittent, it was order of n. Now because of this approach, time complexity of the push operation will become order of n all the time. So this is one limitation. Okay. The second limitation is that every time when you are doing a push, you are creating a new array object. You are creating new array objects, right? If the rate of insertion of your data in a stack is very high, right? It's a very write intensive application. You'll end up creating so many array objects, right? That it might before for example, the different languages have a different way of handling the memory. So if I take example of Java, it's being taken care of by the garbage collector, and the garbage collector in Java reclaims the memory automatically. It is not triggered by the developer command, right? So in that case, suppose if the rate of creation of these stack object is too high, right, it might happen that it occupies the whole of the heap space, and your system can go into out of memory, reasons, out of memory space also, right? And this is known as the memory leak. And this kind of the pattern is also known as the memory leak. So with every request, if you're creating each newer objects, which you could have avoided, right? So this kind of situation, or this kind of scenario is known as a memory leak, in which you are creating more and more objects which would be avoided. Does this make sense, Paritosh?
Yes, yes.
Whatever that I said, like I double it, is also not optimal. The reason is that suppose initially n was equal to 6. As soon as it reached, I made it n equals to 12. Here it is not a much difference. Suppose initially n is equal to say like 5,000. Okay. And when it reached 5,000 step, I made it n equals to say 10,000. And suppose after 5,000, I only had to store 100 more elements. So I had to only store 5,100 elements. So I am storing only 5,100 elements, but I have created an array of size 10,000. So it's just holding a size of 10,000 in the whole space. So that is also again a wastage of space also. Does that make sense?
Yes.
So that is, so again, this is also not a foolproof thing. This also has its limitations. So this also results in the wastage. So if we go with your approach, that will not require any wastage of effort. But at the same time, the whole purpose for which the stack is defined, in which the push should be a constant time, gets defeated. So I cannot go by this approach also, because in that case, the whole purpose of the stack itself is defeated. Because if I'm taking push operation to be linear, there's no point of using stack. I could use any other data structure and that do the same thing. I'm only using stack because I want to do push in a constant time, and I want to do a pop in a constant time. So again, I cannot do this. But at the same time, this is also not 100% foolproof. This also has few challenges.